Okay, just a quick video to help you out with your review sheet. I'm going to be looking at this section right here. So if you want to follow along if you were confused, I've gotten a lot of questions on this. So I think the confusion comes in for 26 and 27. Let's quickly walk through 24 and 25. You're told that the measure of arc AEC is 300 degrees. So let's start with that. Remember, that's a major arc going this way around the circle is 300 degrees. So we can figure out that the measure of arc AB, my minor arc, is half of the remaining part. The remaining part would be 60 degrees. I'm doing 360 minus 300 to get 60 here. And because I have a radius perpendicular to a chord, PB perpendicular to AC, I can say that it bisects chord AC but also arc AC, and therefore I'm able to say arc AB is 30 degrees. From there, the measure of angle APB, central angle, is equal to the measure of my arc. So I've established that this arc is 30 degrees, therefore this angle is also 30 degrees. 30 degrees should be ringing a bell, and what I'm now going to say is that we're magically going to get side lengths from the one side length I know. Usually I need to know two side lengths in a triangle. But if we take a look at that triangle that we're ending up with, the triangle right here, APB, I'm going to take one of those right triangles. I'm picking this one because I do have one side length there. APB, I'm going to redraw that. Hopefully not that crooked. Let's try that one again. So I've got A here, P, B, and I know that this side length is 8. Other given information, I do know that I have a right angle down here, and we just figured out a second ago that we have a 30-degree angle right here. Let's see if I can make that a little bit bigger. Okay, so that's my 30-degree angle right there that I solved for a second ago. That means that this is 60 degrees down here. And now, if you don't remember anything from Chapter 8, please tell me that you remember the special right triangle relationships. That's what we're about to use. Just a quick recall. If you completely forget your special right triangles, special right triangle, I'm going to draw a special right triangle here. A 30, 60, 90, just to refresh you. My short leg I call X. My long leg in relation to my short leg is times radical 3, and my hypotenuse is times 2. So I drew it looking very similar to the one that I have. Now I'm going to compare. My hypotenuse is what I'm given. That's 8. That's 2 times my short leg. So I'm figuring out that you could be making an equation right now that 8 is equal to 2x to solve for x. I'm going to be dividing by 2. A lot of you just did that in your head. That's great. And you got 4 for my short leg. That's AB. No, that's actually a D. I'm sorry. This should be a D right here. The picture was confusing me, but D is actually the length of my segment. B is on the circle that I haven't drawn. So AD I just figured out is 4 is going to be the answer here. Now I need DB. And DB is a little bit tricky. So I'm going to go back to my picture here. And I know I've got a lot of drawing on that picture, so see if you can follow along. DB is the part from the point D, which is the intersection of my chord and my radius, to the circle. It's just that little bit. So I'm going to say it's the extras, the leftover, on my radius. If I take the length of the long leg of my right triangle here, and I subtract that from the radius, which would be PB. So I'm going to take PB minus PD is what I'm ultimately going to do. I know that PB is a radius, and therefore PB is a length of 8. So it's going to be 8 minus something. The something is going to be whatever PD is. Recall that's the long leg of my special right triangle, which means that I'm going to look here, and I've got x radical 3. 4 is my short leg, so then my long leg is 4 radical 3. And that's going to be my answer, 8 minus 4 radical 3, for 27. if it were actual numbers, I could subtract. If it wasn't, sorry, if it was integer numbers. I can't actually subtract a number and a radical. So I'm going to keep the answer just like that. You can type in your calculator if you want a decimal approximation, but that would be your exact answer. Again, just for a quick recap, 8 is the length of PB, the radius of the circle, and I knew that because AP is another radius, and that's 8. 4 radical 3 is the length of PD, and if I subtract PB minus PD, I'm ending up with just that little part, BD. Hopefully that helped. Good luck with the rest of your review.